Okay, perfect. So here, so what is an abstraction? So abstraction, by the name itself you can understand, abstract, it's a prototype, right? So we are actually talking about prototypes which can be used as a template, right? So here when we talk about abstraction, right, so it's just an idea we are actually creating, or a concept, or a conceptual idea we are actually creating where it is not related to any specific instance, right? So we'll be using something called abstract class, right, which cannot be instantiated, no instance can be created for this, right? So in order to actually make any class abstract, we'll be using a keyword called abstract keyword, right? So here when we are creating abstract class, I'll show you what exactly is abstract class and abstract methods which we are going to create, right? So at least one method is abstract, right? Then you have to make the complete class an abstract class, right? Now in a class, right, that's what I said, if at least one method is abstract, then you have to make the complete class as abstract, right? That's one way that we understand it. Second way, if a class is abstract, right, then it can have both abstract methods and non-abstract methods, right? So here what we are doing is when we talk about abstract, right, abstract means it's just a template. You are just defining a simple template. For example, let's take an example of like building a house, right? So when we plan to build a house, what do? We first draft the complete plan on a paper, right? When we say we, maybe engineer or whomsoever is concerned, right, will draft the complete end-to-end plan on a paper. So like, this wall should be this much height, right? This window should be this much age, the rectangle dimensions should be this much, right? The door height should be this much, and the corridor, area should be this much. Everything will actually plot on a paper, right? Now, whatever he is designing on a paper is nothing but your abstract, right? Which means you are just, taking this as a reference. Can we go and live on paper? We can't, right? We have to use paper in order to build an actual house. This house is using your plan paper to build. Whatever you define in your paper, right, you follow the same rules to build a house. So here this is like abstract or a template we are using to build an actual object. Similarly, your paper here is nothing but your abstract class where we define all the rules and then we build the actual instance. So for example, let's take the same use case which we use for inheritance. Let's say I'm going to create a simple abstract class called vehicle. Okay. Now here, while building a plan for paper, what we define, like wall should be of maybe 100 meters height, right? And windows should be so much area. That all these things you have defined. Now these are called as some rules or the dimensions you have defining here. Similarly, vehicle, which is my abstract class, I'll define my abstract methods, right? Like let's say it should have a start, it should have a stop, it should have a move, simple. Or let me go with two, start and stop, right? Now, vehicle class, when I say abstract method doesn't have a body. It just have a signature, right? To say, okay, when you're using this vehicle, you should have a start and stop minimum. I can use this vehicle to build an actual object called car. I can use it, right? So let me show you how abstract is built. So first, let's create vehicle class, right? And let's make it abstract. Now, first step, let's go with the vehicle. So as we already have vehicle, I think vehicle created, we go with something called vehicle 1, car 1. Okay. So let me close all. Let me go to trigger and let me remove this. We'll create one more trigger class for main method. So let me close all documents. Let me create a new class. Add a class. Right, so let me call it as vehicle 1. It's a plain simple class. So when you are actually creating, right, so this is my vehicle, right? So now to make it abstract, I'll be using a keyword called abstract. And in abstract class, what I'll be doing, as I said, I can have abstract methods and after. So here, start and stop are my abstract methods. So see, let me show you how to create abstract methods. So public void start. Now in order to make it abstract, I'll be using again keyword called abstract. And then semicolon, that's it. This is called as an abstract method, where it doesn't have a body. Right? Now this is like a rule you're defining. Okay, vehicle should have a start. That's it. How to start, right? And all we don't know. Similarly, I have public abstract void stop. Again, I'm not going to define how to stop and other stops. Right? I'm not defining it. So this is your abstract method, where you just say, okay, if you have a vehicle, okay, it should have at least start and stop feature. That's it. Similarly, as we design our paper, right? What's in paper? Okay, your wall should be so and so, window should be so. That's it. But we are not actually building 100 meters wall on the paper, right? What we are doing, we are using it to build actual house, right, in somewhere else, right? So that's our concept here. So here, same concept. So here I can have public void normal method, or let's say build year. Maybe I'll take, right, where I'm going to say console.writeLine. Line up. Maybe I'll give some year, maybe 2015. This is a plain, simple, abstract class we have, right? One of the important rule, right? If at least one method is abstract, then your complete class is abstract, right? That's very important. Second point, when your class is abstract, then it is not mandated to have, right, abstract methods. It can have non-abstract methods too. If you want to define a rule, yes, you can define. But we generally create an abstract class to define abstract methods. Simple as that. Fine. Now let me create a trigger class. Add a class. Let me call it as trigger 1. And this, let me create static void main of string array. Console of the line. Right, and then now here let me create vehicle. See, vehicle 1 is abstract class as said, and we can't create an object for it. Let me show you that. So if you create an object, let's say obj is equal to new vehicle, right? Then you can see it will give you error. It says cannot create an instance of an abstract class interface. You can, by looking at this class itself, you can understand. Even if I create an object for this class, right? I don't have any definition for start or stop, right? So there is no meaning in creating object, right? So that's why, right? .NET doesn't allow creation of object for abstract classes, right? But I can reuse this. Now here, when I say reuse or use it, now here what I'm doing, I'm imposing, right? I'm imposing this rule. Whoever uses vehicle should define start and stop. This I'm imposing. That's one advantage we have. The main advantage we have with abstract. Let me show you. Let me create a new class called add a car. Let's say car1. Okay. So in this car1, what I'm going to do, similarly, how can I use a class? It's simple. It can be an abstract class or normal class. Usage into some other classes to inherit it. Simple. So I'm going to say vehicle1. Result. So now let me keep this blank. Right, in my vehicle1, what is there? I have abstract classes, and I said abstract class, whenever you use abstract class in any other plain normal class, now this will force you to define the body for these abstract methods. Let me rebuild this project. As soon as I rebuild this project, right, see, it fails. It says that car1 does not implement the abstract member called stop and the abstract member called start, which means you have to override this or use this. Now how to use it? You have to provide your, you can say override, see, your start. I hope you guys know what is override, right? The method which I have in my base class, right, I'm gonna use in my child class. So now I have overridden my start and stop methods. Now here I can say console.writeLine of right car started, and similarly right, we have car started, so now we have car stop. The bare minimum methods which car should have, I can't leave the car blank. It should have at least two features called start and stop. See, it will force you, when you are using abstract class, it will force you to define these rules. Simple as that. That's why if you are using this plan, it will force you to build a wall of 100 meters only. If you override this and say, okay, I'll build 200 meters, then it will become like, it will not be a perfect house, right? The walls will not match and ceiling will go somewhere and complete thing will be messed up, right? That's how it is built. Now this concept is called as an abstraction. Fine. And now where we can see these are abstract methods which I do have to override. So I cannot create object of my abstract class. See, now let me create a car object, car1, objc is equal to new car, you can see. Now I can actually access, you can see start, I can actually access stop, right? Also, you can see I can access build here. Where is build here? Build here is in my parent class, right? See, this is a non-abstract method. The non-abstract methods can be directly accessed as if we are accessing the parent method. Simple as that. right? So this is something which works in this way. Okay, so now when I run this program, now definitely this car1 will be triggered and all the methods. So from here, car started in 2015. 2015 you are getting it from vehicle 1. This is the concept of abstraction. And when I say abstract class, right, we can use abstract class name, right? We can use this abstract class to hold the child class object, which means I can say vehicle 1 object is equal to this. Now this is the concept of parent can hold object of child, which means when I create, see, when I, let's say I'm going to create one more class called truck1. Let's say into this truck1 I'm going to inherit the abstract class called vehicle1, where it will force me to use override the start, right, and also override the stop. Right, so where I'm going to say console dot write line of truck started, let's say truck stop. Right, so here what I can do, so I just said vehicle 1 is equal to object of car 1. When I run this, right, still your car instance will be triggered. Now let's say I'm going to create vehicle 1 again, where I'm going to say instance of truck, right? So now here when I say obj dot start, obj dot stop, obj dot build here, right? You can see now these are different. Now when I run it, you can see that I'm using vehicle 1 to hold multi type of instances, but everything works as per the instance. If it is truck, then definitely when I'm using this object, this object will point to that specific method, truck started, truck started. Now this is the concept of your abstraction. Any questions here, guys? Now you can see that we are creating one abstract class and we are using. Okay, no questions? Fine, perfect. So this is what we have for abstraction, where we are building the complete layer of. So parallel to this abstraction, right, we have one concept called interface, right? Not same as abstraction, no relation with abstraction, nothing. But the conceptual wise, we have something called interface. Right? So let us see what exactly is a interface. Now in abstraction we have some flexibility to create non-abstract methods, right, and allow them to use it and all. But interface, when it comes to interface, right, interface is strict operation based entity. Now till now whatever we have seen, right, we have seen through classes. Right, and we have understood that okay, class is something which contains members are variables and methods and so on. Right. Similarly, same as class, we have a concept called interface. Again, always do remember, interface is not class. Interface is not a class. Interface is a separate entity which we normally create to create something called operations. Same as this, you can actually compare with abstract class, where abstract class will have abstract methods. Interface will have operations. Operations is again kind of just declaration, signature, no body for them. And in operation, you can't create normal methods. That's an interface. If you want to stick to only just create operations and nothing else, yes, you can always go for interface. Right? So let me show you what is the interface. So now let me create altogether new stuffs here. Let me create a new class, add a class called trigger2. Fine. And now let me take the same example of vehicle. So here what I'm going to do, I'll not create a class, sorry. It's an interface. You can see there is a type called class and also there is a type called interface. Interface is completely different. And convention which we normally use for interface for naming is we always prefix with capital I to define that it is not a class or other than. It's interface. So and we'll say vehicle. Let's say I'm going to say I vehicle 2. Add it. Now you can see it's altogether different. There is no concept of class here, right? We are creating a simple interface. Interface is again like a model or an idea we are creating, right? So yes, interface I vehicle 2. Here I can create simple something called start. Now here when I say public here, right? See, when I say public, you can see here, you don't have to define any access modifiers in interfaces, right? Just give what is the return type and operation name. That's it. Void start, void stop, done. Right? Now these are the two operations we have for interfaces. Fine. And now let me go to trigger. Let me keep one static void main string array of a console.readline. Fine. So here we created one interface. Now if I can't create an object of this interface is same. You can't create object of an interface, but only you can use it, right? And again, this will enforce you to implement this, right? So interfaces, there is a difference between interfaces and normal classes. Let me show you that. Let me create a new class called car2. In my car2, I have to use this class. Again, using this class is again with your resolution operator, and I'll say I vehicle 2. Now, very important stuff. Now, this is not called as an inheritance or you are inheriting this. We should always say car2 is implementing. This word is important. car2 is implementing interface I vehicle 2. Right? But in abstraction, you can say car1 is inheriting vehicle 1, even if it is abstract class. But if you are doing interface, see, interface is altogether different. It's an interface entity, and I'm trying to implement this into a car, which is a normal class. I can do that, right? Now here, this is implementing. Now, if you build it, so here itself you can see, right? When you get an ob, when you see here it says implement interface, right? When you implement, click on it, it will automatically give you this values. Anyways, let me just remove it and let me build it first. And I build it, you can see it will give error. It will say it will give you error, says okay, you have an operation called start and stop, and you have to implement it. It will enforce you to implement the. Anyways, either you can click on this to get it, right? Public void so and so, and then you can say console dot write line of, right? Let's say car started. start. Simple. Fine. This is now this is how we normally create an interface and user. That main advantage here is interface will not allow any normal methods. It will have only operations with signature. That's it. Nobody. Unlike abstract class. Okay, so here again we can create car object car2 objc is equal to the car2 and call it simple objc dot start. Right. So when I run it, now they have implemented in a car. Similarly, I can have iVehicle 2, right? So when I run it, you can see interface can hold the object of your car, right? Because interface is the parent and I can use the name to hold, same as abstract. This is your interface concept here. Right, there we will be creating a separate interface with operations. That's your abstraction interface. Let's go to the last one, encapsulation. Now, what is encapsulation and how do we use it? So, encapsulation, with the name itself, you can understand encapsulate, right? Hide or preserve something, right, which is not exposed to the outside world. You can give any name. Right. So here, when we talk about encapsulate, right, we are specifically talking about hiding or storing data. Right. So here in encapsulation, right, we'll actually learn two concepts like enums and properties. Very important. Because properties are also called as encapsulated fields in .NET, which are actually used to encapsulate data, right, or provide features or provide data visibility to the outside world. Fine. And we'll use enums to specify what action is being done and all. Okay. Fine. So let's create a simple use case first. Now let's talk about use case of salary. Okay, this is the best use case which you can use. Now take a simple example of a company. Let's say in that company you have three different roles. One, team member, and then you have manager, and then let's say you have admin. Fine. So these are the three roles. Now, so team member, let's say there are two functionalities which you can build: view salary, right, and edit salary, right. We can do either one of them. So let's see who can view. I'm just drawing a simple table here, kind of, so that we can actually map things in an easier way. Okay. So view salary. Now when I say view, viewing some other salary, not own. Now, can team member view other salary? No, let's say no. Can manager view? Yes, view is fine. Can admin view? Yes. No. Edit salary. Can team member edit other team member salary? No. Can manager? No. Can admin? No. I'm just taking this. This may not be a real-time scenario. Maybe a manager can also edit salary, right? But that's fine. Now here you can see that there are multiple combinations. There are almost like 3 by 2, 6 different combinations which we have. Right? First combination, team member to view salary, no. Manager to view salary, yes. Admin to view salary, yes. 3 combinations. Similarly, team member to edit, no. Manager to edit, no. Admin to edit, yes. Now here you can see there are 3 different combinations we have. And now what we have to do, for the 6 different combinations, you want to write 6 different or at least 3 different classes, or either go by horizontal or the vertical, 3 different classes or 2 different classes for viewing array. You don't have to do. We will be writing one simple class to actually achieve all these combinations in one shot. That we're going to do using right. So that we are actually going to do using our encapsulation model. Now, first let's come from basic idea of property, and then we'll actually go step by step of hiding it. Right? Now, so first let me go back here. Let me create a new class. Right click on this and say add a class. Maybe let me call it as a salary class. Fine. And let me create one more trigger. Let me just remove the static void name from this trigger. Let me add a class called trigger Quora. And here let me create static void name string array and say console.writeLine. Fine. Now I have a simple class. Now first let's go step by step. So here let me create a simple variable called public, or maybe I'll take a double. Okay, let's say salary or maybe I'll call it as sal is equal to some value, maybe 10K for example. A simple variable. Now here in my trigger, let me create a simple object of salary. Let's say SOBJ is equal to new salary, and let me print this console.writeLine of SOBJ dot sal. See, the sal variable is visible. How? Because we have made it public and the variable name is sal. So now let's run this. Now I'm going to go step by step so that we can understand encapsulation in better way. Right? So now when I run it, right, it'll actually get my variable sal, a value of the variable, right, and it'll try to populate the value on console. Right? So just give me a moment here. It will run and it will get the console. One second guys, it is taking time to, okay, fine, perfect, got it. Right, so here you can see it will get the value of sal, which is a public variable value 10%. Right, now what we're going to do, we are going to create a property for this. Right, now let me show you how to create a property. Property is a simple, again it comes under a variable family, right, but with different feature altogether. So in order to create a property, you can directly create a property using shortcut. So let me show you that. So for whatever variable you want to create a property, select on it and press on Ctrl RE. So when you press on Ctrl RE, you can see this will give a pop-up and it says encapsulated field, right? So here you can see which field we want to encapsulate. It's sal. And it says which property, what is the new property name? Anyways, it will take the same and it will give caps to this, but anyways we'll add prefix called PRP, which is property, right? PRP sal, which is property of a sal Excel, right? And update all references, which means wherever this sal is used, I want to update to this is a property kind of. Click on OK, and it will show all the references wherever these are. See, as soon as they create an encapsulated field or a property for this sal, right, immediately this public access modifier of this sal is going to get converted to private. First step, because I don't want to expose this variable sal to outside world directly. I don't want to do that. That's why we are creating a encapsulated property here. And definitely wherever you are using this sal outside world, let's say in trigger 4 we are using this sal, right? Now you can see here in trigger 4 console.writeLine of SOBJ sal. Now this will get updated with this property called PRP sal. That's what you should. Click on apply. As soon as apply, you can see property created. It's like a simple, it looks like a method. In this property you have two steps, getter and setter. Very important. In the property we have two main pillars, getter property and a setter property. Getter, you can see, is the first step which returns your sal. Now you can see the variable became private. Now when it is private, can I use it directly? I can't use it, right? Now if anyone want to use this sal, he should go through PRP salary. See here, as soon as I go to trigger 4, the name change here, right? I can't use salary anymore, sales anymore. I have to go to the property. Now when I go to the property, when I am reading it, right? What is the meaning of reading? Reading is nothing but when I want the data, it will trigger get. Get will return the value of this. When I want to set the data, what is setting? SOBJ dot, let's say PRP sal is equal to, let's say I am setting something, let's say 20. Now set is, it will set the data. That's your getter and setter. If you want, I can show you by debugging. Let me just click on this return, click on this val, and let's say I'm gonna, after setting it, I want to print it again, for example, right? So first, let me start debugging. So I have it here, F10. So now what I'm doing, I am trying to get the salary, right? So when I press F10, you can see what is the sal value? It's 10,000, right? Now it will return 10,000. So here the value is 10,000, and in console you can see as of now it doesn't print anything because we have to move from this line, right? Click on it and you can see 10,000 printed. And now what we are doing, we are trying to set the data, new data, which means we are setting some salary. F10, immediately it will go to the setter. What we are setting, to whom we are setting, to sal. Perfect. What we are setting, there is a again keyword called value. This value, you can see it's 20k. Now this is the one which you are assigning here. It will be automatically assigned to sal. Now as soon as I go down, you can see salary became 20k. That's it. Now when you populate it again it will go to return because it's a getter again. And when you go to sal, now salary got updated to 20k, right? It's not 10k anymore because you have updated it. So that's how it works. Simple. Now you can see 10, 20. We are not even touching that variable called sal, but through property we are able to get and set the values. This is called as a property, or encapsulating a field called sal inside PRP sal. Now anyways, now here we got a functionality of encapsulating. So here it can be either getter or setter. See, I can also remove this. I can remove this, which means this property is a read-only property. No one can set anything. See, as soon as I remove this setter, there is, you can see there is no, it says, right, PRP sal cannot be assigned because it is read only. That's a big advantage we have here. Users can only see the data, that's it. No one will be able to set the data. Right, that we can achieve only through a property. Right, I can't achieve that by making this as public. No, I can't do that. Right, so in property, it only says only get, no set. That's how you make a property read only. Perfect. Now this is how we normally do create a property. Now let's go now till here. Yes, we have already done with encapsulating data, but now let's go one step ahead to see how the same property, encapsulated property, we can use to improve the functionality here, right? With the functionality of role, right? Now, how many roles we have thought of? 3 different roles. Now here we'll understand the functionality of enums. Okay. So enums here is nothing but C# feature we have, or .NET feature I would say we have, using which we can create user defined variables. We can create we can create our own data types using enums, right? And enums hold only strongly typed constants, right? So we cannot assign any other value, right, apart from the inner box values which are defined inside your enums, right? So let me show you the enum. So here the syntax of the enum is, we create public enum. Let's say role is a enum. So inside role I'll create TM, comma MNGR manager, comma AD. So these are my, so this is a enum I have. So same as you can see that it is syntactically same as a class. We define class name, then enum name. So for this enum I can create my variable. See, role. Let's say RL is equal to, and it forces me to use any one of the constant defined. Let's say by default I'm gonna make it simple as that. So here I'm gonna make it public. Now you can see that this is the role I'm using for my property. Right? So this is what I am actually using. So we can just close all. Right? Role, which I'm actually referring. Now I'm going to use this role property or a role enum variable. I can see this is like same as you can see when I define something called int I is equal to 10. Just compare this with this, and let's say I'm going to make it public. See, int is a system defined data type, I is a variable, and this is a value. And you can compare with role. With it, role is a user defined enum, but I'm using it as a user defined data type. Of what type? Of enum type. And what are the values allowed? These are the only values allowed. I can't give boolean or a string or anything else for this. No, these are the only allowed values for it. That's your enum concept, right? Now what I'm going to do, we are going to start building a functionality. So by default, what did we do? We actually have set team member. Now let's use this property to build functionality for all. Now get property. Let's go back to this table and see. When I say get, which means I'm building a functionality of views only, right? So this is something which is kind of a get, right? And this is something which is kind of a set. Now, who can view salary? Everyone except team member can view, right? So here what I can do, I can say if RL is the role, right, is not equal to role.tm, then we can start, right? Else what I can do? Console dot write line no read access, okay, and just say return -1 because you have written something. So now you can see with this functionality what is happening. If I set role, I'll show you. We'll see how, where to set and how to set and how to get. Now who can get the values except team member? Whoever's try to access this, everyone can get the salary. Otherwise, if it's a team member, then there is no access. Simple. So now we restricted everything for this guy. Now who can edit salary? You can see edit salary can be done only by admin, right? So set sal, what we can do, if my role RL is equal to role.admin, right? Only this guy can set. Else, the console.write line of say no edit access. Simple as that. So now here, who can edit? Only a role with admin can edit. So by default, you can see you have set team member. Now let's get back and see all the functionalities here. Now first step. So here in my object, I'm gonna set the role as object dot. If you remember RL is my variable which we created, right? Now, what is the role I want? See, I can get it directly. Let's say first team member. Now, I'm setting this team member. So first what I'm trying to do, I'm trying to read, edit, and then read again. So can team members do any one of them? He can do nothing. So when I run my program, see, no read access, no edit access, no read access. Simple. Because team member doesn't have either edit or view access. Perfect. Now this functionality achieved. Now let's go to the next one called manager. Role.manager. What can manager can do? Manager can just view salary, but he cannot edit, right? So when I run this program, you see 10,000. Yep, because he's a manager, he can view. But when he tries to edit, no edit access. And again, when he tries to read, again he is able to read. Simple as that. Right? That's your manager. Now let's go to admin. Who is admin here? Admin can view and admin can edit also. So when I run it, now you can see perfect. Your 10K is your previous salary, edited, perfect, and then when you retrieve again, 20K. 10K. This is how we read and edit the data. Here. Now this is how we normally update. Update the one single salary you can see, but we are achieving 6 different combinations of rows. And now if you increase the rows, yes, the same way we can actually have a feature handling. This is how we normally do encapsulation. Now this process of actually showing data and hiding data is called as your encapsulation. Right. So this is the concept of encapsulation and all OOPS operations. Any questions, guys? Perfect. Good. So this is how right? We normally do work with OOPS operations. So that's the complete concept of OOPS.